Hello, welcome to the Data Channel. And so today we're excited to bring one more very important topic. So in the modern data models or modern data concepts actually, and this is about a data mesh, right? So data mesh is widely discussed in the data community, especially from the architectural community, where there is a lot of revamping happening of the existing modern data platforms, and a lot of the organizations are actually talking about modern data mesh, and so data mesh has already been implemented in very big enterprises already, and so it's been widely discussed. So that's why we are bringing this video to kind of bring a kind of awareness, whoever wants to understand this data mesh in detail and in a simple terms, right? So basically, what is data? Let's understand the little bit slight history about it, right? In the past, almost 8 to 10 years, in a decade, what happened was because there is a cloud evolution. There is a AWS, Azure, Google Cloud came in, and especially for the data related stuff. So there is the scalability of the storage systems become cheaper and scalable because of the cloud evolution. And what many enterprise organizations started doing is heavily invested on centralizing the data. So they started bringing the data into a centralized repository or the data lake, and kind of created a centralized data teams, and they were expecting to drive the innovations and bring the smarter decisions using data. So that was a very good idea that time, like from last 8 to 10 years, back then when it was started. So it was very good idea, because the idea is, suppose you have different systems, like you have legacy systems, you have database systems, you have different teams, like you have a sales team, products team, manufacturing team, logistics team. So all the different teams, the data is getting generated, and so if you want to get meaningful insights and to make a smarter decision, so you are expecting data to be in one place, so that you can perform a lot of analytics on that, and you can derive the incremental decision makings, right? But initially, yeah, it was actually after this investment and the implementation of the centralized data lakes happened, and it was giving very good results. Like if you take like past 3 to 4 years from now, so it was giving very good results. Initially, it was very good results, and it was having a lot of quick wins. And even the leadership was happy because they were getting the dashboards, they were getting the live reports, and the management was able to see the power of unifying the data in one particular place. So technologically, there is no problem here, right? So technologically, you are it's more of an integration challenge. So integration challenge of bringing the data into one place. So technically, so that was not a problem, right? But then what happened is, like soon after the crackdown started, that is the centralized the team become overwhelmed, because there is a lot of requests started coming in, change requests started coming in, bug fixes or enhancements, all of these changes started coming in, and they were not ready to take it. So, and these were piling up the long queue of this particular data central team, and so answers were arriving too late to be useful in the past phased decision making. So exactly that is the concept we are discussing today, right? So what happened actually, and how the data mesh concepts came in. So data mesh concept, like what is it is trying to solve here, right? So that we will understand. So if you are new to this channel, we would recommend you to please subscribe and also press bell button for instant notifications. So let's get started here. Right. See, this is what we were discussing, right? Like, suppose what happened with the centralized data team is, so there is a this is a centralized data team, the square box that you see, and what they were essentially doing is they were building a data pipelines which will ingest the data from multiple sources. It might be a ERP system, it might be a products coming from product stream, and there is a sales data coming from SAP systems, accounts and invoices data coming from SAP systems, and there is a different domains like products, manufacturing, logistic, all the data are like dispersed in different geographical locations, and the centralized data team is kind of responsible in integrating that complex scenario and integrating that, bringing it in one place by having the ETL or ELT kind of pipelines. They build the pipelines, and they kind of schedule these pipelines, orchestrate these pipelines to bring the to bring the data automatically on a daily basis, or a real time or near real time basis. And they will store in a centralized repository. So that is what we call it as a centralized data lake. Usually, it will be a data lake in the modern data platforms. And so then, on top of this data, which is in the centralized data lake, individual businesses will be given access. There will be access control, and so they can build their own reports. If there is a leadership coming from manufacturing, if the leadership coming from sales, if there is a leadership coming from finance, so they have their respective access control defined. So they kind of build their own reports and get the meaningful insights of it. And yeah, definitely there will be a governance, security, central, all this aspect is owned by centralized data team. So now you understand what centralized data team is doing here, right? So they are actually creating the pipelines, they are ingesting the data, taking care of all the governance, security part of it. And it is not one pipeline, right? There will be hundreds and thousands of pipelines, and they have to take care of all these pipelines on a day-to-day basis, and they have to also they're responsible for any business request coming in. So that is where the game changed, right? So once they built it, so then there's a lot of requests started coming in, right? Business started giving a lot of requests that so I want data in a particular format. I want some particular. There's a lot of questions that business started wanted to answer by seeing the data, etc. Right? So that is where the problem started, right? And now let us see what exactly the problem, right? The problem is, let's say marketing team started coming and asking the centralized data team which customer segment responded best to the last email campaign that they have driven. And product team has their different question to, like example, which product features are driving repeated users. Sales team is coming and asking which type of lead are converting to the fastest in this particular quarter. And logistic team operation team is asking are out of stock notification causing the cart. And the customer support is asking what are the top drivers of customer complaint post purchase. So these are different questions different teams started asking the centralized team. But centralized team is first of all they are not kind of well versed with this domain knowledge, right? And also it is not just about the change request and the getting the new pipelines added and etc. Not about taking care of technical details. So they also kind of overwhelmed to answer all of these questions and to build the new pipelines to cater new requirements, right? And there is a lot of requests started flowing in, right? So that's become the bottleneck here, right? And so each of these needs, okay, whatever they are asking the questions here, so the expectation is they need a clean, up-to-date data, any business requirement, right? And they want to do a fast analysis because they will not have the time to kind of they want to have a competitive advantage based on the clients that they have or the customers that they have or the competitors that they have, and they need to have a deeper understanding of the domain knowledge. Because see, this core centralized data team, they are more of a technical heavy team. They can understand the particular domain knowledge but not all of this domain knowledge, right? And they cannot be experts definitely in all of these domains. So that was the expectation when the business is coming and asking. So the business is like doesn't care because business thinks I'm getting the data from this team and I want this answer from these teams, and these are my needs. So that is particularly straightforward from the business point of view, right? So this is how the requests are coming from the business, and these are coming from different teams, different like product teams, basically, right? So, and each of these questions requires accurate and up to date from the right source, and they are expecting to quick turnaround time so that they can create a business use case decisions. And they are also expecting the deep domain understanding that this particular central team doesn't have, right? So these are the questions that they are asking, okay, and this is the expectations. And much of their time, much of the who time, the much of this centralized data team time, basically they are busy in fixing the broken pipelines if there are pipelines broken here, and chasing the down the scattered documentation, because they don't have the documentation, because they brought the data from the marketing team, they bought the data from products team, sales team. So it was just a they bought the data like without having any kind of a documentation, and they actually started struggling of understanding the data catalog, data lineage of part of it, and it is quite difficult to reach out for all of these teams and collaborate and get the required informations, catalog data, etc. Right, and they are trying to understand the domain specific knowledge, which is the expectation, but in the real time it doesn't it's not easy, because domain knowledge is mostly built over the time, and so you cannot expect data team to kind of become expertise in the in all of these data domains, right? So that is practically kind of not possible. So basically because of this, all of this expectation that we have here, so it becomes practically impossible for the centralized data team to cater this solutions to cater any solution, basically, right? And that become the final problem. So this is a problem here, right? So the problem here is the slow answers, because you are asking these questions. Data time, sometimes they can give the answer, sometimes they don't have the answer, and whenever they have the answer, it becomes slow, because they have to go back, analyze the data lineage, where the data coming in from, what is the data quality, they need to clean the data and see how it looks. And we get a shallow insights because of their domain expertise. They don't have the domain expertise, and finally the stakeholder is frustrated, right? For the obvious reason, because the initial intention of the centralized data platform is to make quick decisions, because the data, all the data is in one place. But practically that was not working here because of all of these reasons. And data quality was on toss, and you don't have quick turnaround time, and so definitely all of this caused the opportunity miss opportunity, and fast and uh, like inform action cannot be taken. So this is the problem. Okay, we are talking about this problem, and this problem is what data mesh is trying to solve, right? So let's see now what exactly the data mesh architecture is kind of a it's a what is the problem here, right? And let's take an analogy of a centralized kitchen. That means centralized restaurant is there. Let's say, for example, there is a Domino's or Starbucks, right? Any kind of restaurant or coffee shop that you can take as an example here, right? And you have a centralized restaurant, okay, in a particular city, in a big city. And what happened is there are orders started coming in from different parts of the city. So let's suppose this is a north part, this is a south part, east part, and west part. Okay, from all of these parts of the city, the order started coming in. So because of this, what happens is all the requests are coming to this particular one location, the centralized, because there is only one centralized kitchen, right? There is only one restaurant. So all the requests started coming in here, and the restaurant is catering those services initially. They are doing good, but eventually there is a lot of requests started flowing in, right? So from all the direction, there is a lot of requests started flowing in. Okay, so it was practically impossible to for them to handle that because of the lot of requests coming into one particular restaurant, and that become a bottleneck for them, obviously. And this is the analogy that we want to explain the data mesh problem here. So this is what exactly that in the previous slide we were discussing. The same problem that the analogy is here, the centralized kitchen or the restaurant. So this is where the data mesh comes in. So it kinds of a um, so so basically what's happening here is the deliveries is slow because there's only one kitchen, and the taste doesn't match the local taste, because see, the north part of the city people might be of a different taste, right? Their the preference of taste would be different, and east part would be different, and south and west, right? And there might be, like, suppose let's take example, if in south, so they are more preferring the kind of a veg rather than the non-veg. In the north, there are a lot of non-veg. Okay, for instance, I'm giving, right? So based on that, the preference of the food, also the menu, also they need to they cannot cater this because it is centralized kitchen, right? And kitchen gets overloaded. So in the previous slide, we saw the centralized team was getting overwhelmed by the request. So here, the kitchen is getting overloaded because of lot of request, and also because there is a lot of request, and the quality might be compromised, right? Because it is not scalable, basically, right? And chef's skill is specific to the area is missing. So chef is, they are just cooking the food irrespective of whether the request is coming from north, south, east, west, right? Because they don't have that particular skill or the knowledge from where the request is coming, and they don't have that skill also to cater that particular service. Yeah. So this is a problem, right? If you take the analogy, and coming to the solution. So what solution there we are bringing up is the franchise model, right? Or the branch. They are creating a different branch. So this particular restaurant, which was a centralized operations, a centralized restaurant was there. So that becomes the headquarters now. And now what happens? Let us see. So again, the orders are coming now, right? Orders started coming in, but this is a solution is the franchisee model. So now we are no more the centralized restaurant. It is a franchise model, right? That means there are franchises. So all of these are franchises. So this one, all franchises. So there is a small branches opened for individual locations. Like North has its own franchise branch, and South, East, West, right? They have their own franchise restaurants in that particular local region. Okay. So now, whatever the orders are coming in, right? So what is happening is the local restaurant is kind of catering that. So no more it is coming to the centralized restaurant or this thing, right? So like because of that, so there is a lot of advantages because it is more scalable, and they are kind of able to drive the request, right? Based on the whatever the number of, even though if the requests are more, because now they have the branches, so they can cater in long number. So because of this reason, so now what happened, right? So each location domains run its own kitchen, right? And they follow the company-wide hygiene rules, data standards, um, right? And they cook what they want. They know for the best for their local audience. So this is decentralization, right? And it's product-oriented model, right? Basically, if you see here, so area-specific branches are there, and taste is catered or tailored to a specific area, right? So if this particular restaurant is menu is slightly different, or the taste is different, and this particular restaurant taste is slightly different because the order is specific to that region, right? And that gives the more customer satisfaction also, right? And so here the kitchen is decentralized. So kitchen is no more centralized now, and the quality is owned by the local restaurant, because the local restaurant is cooking the food now. So the local restaurant has to take the ownership or accountability of the quality and the delivery time of that particular food, right? And the chefs also, they will be trained for a particular area specific menu. Okay, see, the restaurant in this north region, the chefs are trained to prepare that particular food specific to that region. Similarly for the other areas, so they becomes the domain expertise for that particular areas, right? So that is exactly what's the solution here, right? But you might think what this centralized restaurant is doing now, right? That is a bigger question, right? So that is doing all these things now. So they started defining the standards and branding. So they kind of creating the brand and defining the standards. What should be the quality of the food? What is the price of the food? What is the delivery time of the order should be? And also provides the tools and trainings and the raw materials that is required, and also the financial scalability they take care, and helps and maintain the shared order management system. They take a order and they distribute it to the different systems. So they maintain that order management systems like a common data catalog. So they keep that data catalog in the rest in the centralized repository, and they take care of it, right? So that is more of a what we are talking about, the solution part of it here, right? So here the advantage is this is decentralized and it is product oriented model, right? The data is close to its source. That means food is close to its customers, right? And domain experts are accountable for the data quality. So here the chefs are accountable for the specific or the individual branch are accountable for the orders that they are getting from the area specific people, right? So that is the analogy. So that analogy we will discuss in detail now. Yeah. So if you see here the analogy, just we discussed the central kitchen, right? So central kitchen is nothing but that becomes the central data lake of the team, right? Data team that we saw. And the local branches that we are seeing now, it is a domain owned products, data products. And the local chefs that we were seeing is more of a domain data experts. Like for products, there will be experts, there will be sales, manufacturing, logistics. So you started creating the local experts or the domain experts instead rather than having one set of experts, right? And the branding standards and menu rules that we were discussing, that becomes your governance, interoperability rules, security, and compliance related things. All this comes as the standards and the branding concept, and shared order. So that comes in the when you talk about data mesh, that becomes the data discovery and access tools, etc. And customer ordering the food, so that becomes the data consumers. It might be a data analyst, ML teams, or the business itself who are consuming this data, right? So the central team here provides the platform and guardrails guardrails, but it is not getting bottleneck, right? And the domain experts are accountable for the data quality, and so they follow the company-wide hygiene rules and the data standards. So that is the analogy here, right? So if you compare this particular solution now with this analogy, and next is important, right? So next we will move to this particular analogy and see. So this particular analogy you are seeing here, right? So that is the same thing that we saw just a while back, right? There was a centralized and we completely decentralized that. So that is what we will see here in the decentralization part of it. So what happened here is, so this particular data mesh that we are calling is a centralized kitchen that, or the, now it is a headquarters. So that is what is happening, right? So this act as a headquarters, and you have a marketing team, you have a finance team, you have a service team, you have a sales team. So that individual become like a individual branches, right? And each individual branches have their own operational application, analytical applications. They build their own ETL pipelines. They create all the scheduling of the pipelines. They take care of data quality, etc. But so that is about individual teams. But what happens about data mesh? So there is data mesh is kind of integrate all of these things, but not the physically they don't integrate the data here, right? So still the data is sitting in different buckets here. The marketing data is sitting in the marketing data mesh, finances data is sitting in finance data mesh, sales and services sitting in their own data mesh, right? Basically physically data is not centralized here. So what is centralized? The centralization in the data mesh is only about data privacy, data governance, the governance or the federation part of it, data federation part of it. So there is a separate committee will be formed, so which acts as a governing body to kind of make sure that the delivery quality standards, data governance, federation is actually happening, and each individual domains are taking care of all of that data standards or data the standards that are being defined, right? So that is what the governance system will be formed. The federated system will be formed or set of a people. So they will kind of act as a centralized team here. So they are just monitoring and governing these things, but data is still in their respective domains, right? So if you can compare this with the analogy that we see in the restaurants, right? So restaurant is still delivering their product to their local customers, but how they are doing it, what is the quality, what is the standards that they are following, what is the menu, pricing, everything is actually governed by the centralized the head office that we have, right? Head office is physically not doing anything here, so they are just facilitating the operations by just having the governance, standard practices, all this set here. So this is where you can compare this particular data mesh architecture with what we just discussed, this particular restaurant or franchise model, right? So hope this analogy was helped you is able to help you to kind of understand in a simple words what data mesh means, right? So this is very simple explanation to kind of a layman's explanation to kind of make you understand. So hope definitely it will be helpful. And so when you're talking about data mesh, right? So these four key principles we need to understand. So if you're taking notes, this is a particular slide you need to take a notes, because so when you talk about four key principle or foundations of data mesh, so these are the four foundations. First is domain ownership, right? What is domain ownership? Domain ownership is like data is owned by the teams that know it's best. That means if marketing team is owning marketing data, sales team is owning sales data, logistic and operations team is also owning that particular data. So that is the ownership they have to. It is a domain oriented ownership. Who owns the data? They have to take the ownership, right? And marketing owns campaign data, sales owns CRM data, they have to take their own responsibility. So just like microservices, teams manages their own data end to end here, right? And data as a product. What is data as a product, right? So every data is treated as a product here. So which is having a clear documentations, SLAs, version control. It should be discoverable, trustworthy, and usable. So in the previous videos, I have kind of discussed what is data product and what is data as a product and data as a service. So on the top right corner, you will see the link to click on there. So you can click on that and you can go to that to know more about data as a product and also data as a service, right? So you can know more about that by going to the previous video in the same playlist, or you can clicking on the top right corner. And what is self-serve data infrastructure or the data platform? So to make this work, the central platform teams build their own tools, infrastructures, things like data pipelines, monitoring, cataloging, and access control, all of this. And what exactly the goal is? The goal is to let domain teams build and serve data without being a data engineers. So data teams, the business started owning that, so they can have their own data engineering team and data infrastructure team, etc. But ultimately, the business or the domain expertise own the data, and they kind of self-serve the data infrastructure, whatever they want. So it will not be provided by the organization level or the centralized data team. Okay, so they invest there, they get the results, and they are completely owning all of that, facilitating whatever is required, right? And what is federated governance, right? So federated governance is very important, right? Because decentralization is powerful. Okay, we have decentralized it, but without governance, it becomes a big mess or it becomes a big chaos, right? So what happens is data mesh become data mess without having this federated centralized governance or computational governance. So that's why data mesh supports federated governance. That means you have a shared policy for securities, data qualities, lineage, and how to like having compliance, how to be compliant, all those things, right? So all this, the federated governance team will be there, who will be kind of a governing all these individual decentralized part, that is a domain related like the data teams that you have, right? So if you're taking notes, as I mentioned, these are the four key principles of data mesh: data ownership, data as a product, self-serve data infrastructure, and federated data governance. And data as a product, if you want to know more about it, so there is a link in the description as well, so you can click and know more about it. So now, so this data mesh architecture we have seen, right? And if you see all of these individual domain teams here, right? Marketing has its own domain team, finance has its own domain team, and sales and service. So now let's kind of zoom in this architecture, right? This is zoomed out architecture. I'll go and zoom in now. That means I will see what this. I'll take one domain, this marketing domain, and see what exactly it looks like, right? So now, if you see, it looks something like this. So what's happening here is, so the marketing domain team that I have taken here, right? So I'm zooming in. So this particular domain is marketing domain, and they are kind of building their own analytics. They are building their own data contracts with other domains they might have, because marketing team, if they want to build their own data domain expertise, so they might get the data from other domains as well. So that is their own responsibility to bring that, and they have their data contracts with their data domain team, and finally they kind of create all the pipelines, data product, and the final outcome is the data product, right? That is what we are calling as a data as a product. So each domains have to build their own data as a product, DAAP, data as a product. So here finance team is also building their own data product. So final, this is a data product that they are kind of creating, and this data product can be used by other domains or the businesses that are kind of using that. But ultimately they own the quality of the data, so they kind of follow all the best practices. They have their examples and they have their enabling team to do that, right? And basically, if you see the data flow, so the data flow is from operational data, data product, and then data contracts, and finally we have a as a final product. But here, the bigger picture, if you see, this finance team is having, this is one domain, right? It can be similarly, there can be a sales, there can be a logistic, etc. So each domain is doing the same thing here. So it can be any of these domains. All have to do the same thing, and all of these domains have been monitored by the federated governance sitting on the top. So what they do is they verify the security policies, they create documentation policies, they create interoperability policies. That means how do you interact with other domains, and they create compliance policies. So all that, there will be a governance group. So they will create a standardized set of policies or rules, and they will do a quick regular audit checks to see all of these domains are following that standards, right? So if you don't follow, if they don't, each individual domains don't follow the standard practices, so then, as I was mentioning, data mesh will become data mess. So this is very important, right? And so, like, these individual domains are kind of responsible to kind of maintain the data catalog, data contracts with and monitoring that, policy automations. Maybe they can have their own separate data platform team, but end of the day, so this entire piece is taken care by the domain teams, right? So they have to build the final product. So this is the final product that they are building. But all of these things that each individual domains are responsible, but it is being governed and audited, and regularly it will be governed by the federation governance team that is sitting, right? So this is about the data mesh architecture, the final architecture. This is zoom out architecture. This is, and if you take individual domains, how they operate, this is zoom in architecture, the final one, right? And now we will move to the implementation challenges. Okay, we are talking about data mesh, whether it is easy to go and implement it. Definitely not. So it's not an easy or quick win, because data mesh, if you see, it is more of a techno-social activity. So it is not just about technical activity where you kind of migrate the data from one place to another place and you have set of pipelines that is kind of automated, right? So it is a techno-social. That means there is a technology involved here, definitely. But there is a social aspect coming in, because you need to take care of lot of social aspect here, because you need to here what exactly you're doing is you need to convince a lot of people, because the ways of working is getting changed. So it is not like IT team or the data team will own the responsibility. The individual teams that is giving the data has to own the responsibility, right? So it's a social shift, or it is a complete shift of ways of working. So that is why you will definitely see the cultural shift or the mindset change is required. So moving from the centralized data team to a domain-owned data requires a big, it's a cultural leap, cultural shift. And each business units that and the data domain teams must accept the ownership of the data. So something they are not traditional responsible for, right? So this is the typical challenge that a lot of big organizations are facing today. So they say, okay, I no, this is not my responsibility, right? So, but you have to own this, because otherwise, who is the best expert to kind of own this data, right? If it is sales data, sales team has to own it, right? So that is a cultural shift, and people are mostly not ready to accept this. That is where most of the organizations are kind of seeing initial failures or initial delays because of this reason. That's why we are talking about it's a techno-social activity, just not technical activity, right? And the next is lack of data literacy in particular domains. So what is data literacy means? It might be a lack of skills to build and maintain the high quality and usable data product, and without proper training and support. So the quality of decentralizing data might actually not might happen, right? And the next is governance without centralization. So what is governance without centralization? One of the biggest risk here is inconsistent definitions, matrices, standards across different teams, and implementing a federated governance system itself is complex, and it needs a strong leadership and tooling. So especially the leadership is required, and even though you have a leadership, to facilitate that, you need to have a supporting tools, kind of a techniques, standardized policies to be applied to across a different decentralized team. So that is also quite a big challenge. And you need to have a robust self-service data platform to empower individual teams, to include tools for data discovery, tools you need to have metadata management tools, MDM, that is, and you need to have a data quality monitoring tools, access control and lineage tracking tools. It might be building or buying these capabilities takes a lot of time and investment, right? Because of all of this. So that is another challenge. And redefining data as a product. So most of the teams aren't used to think data like a software product. But now, since the principle is changing, to adopt this principle, you need to take the clear responsibilities, and you will have SLAs for data availability and data quality, and a lot of non-functional requirements, and you are expected to produce a lot of documentations, etc. And also, it is a feedback loop from the data customers. You need to ready to take those feedback loops and kind of make the improvements. So that is another challenge. And cross-domain collaboration, right? So this means in real business questions often span multiple domains, right? There is a particular report you want to build, or particular question you want to answer from the leadership, which is coming from the leadership. So then you might just need a sales data, you might need manufacturing data, or you might also need the logistic data. So data mesh doesn't remove this need, so it increases the importance of good cross domain collaboration, right? Because here we are talking about creating a silo. We are not talking about creating a silo teams here, right? So data teams are decentralized, but still they need to operate in the cross domain collaboration. So that is also quite important, right? So that is not to forget here. And next is early production productivity dip. So instead of taking all of this challenge, a few organizations went ahead, and they are trying to implement this, but in a maybe in agile or kind of a DevOps transformation using their teams, but often experience the initial slowdown because of the benefits that is visible to the business. So business is making the investments. A lot of companies have made the investment in bringing the data mesh, but you cannot expect the productivity of in a day one. So this is not a, as I said, it is a techno-social activity. So you cannot expect just a technology is not involved here. You have a lot of people, governance team, the culture, all these things coming in, right? So that is why this cause can like executive or the leadership can become impatient in short term expectations if they are not managed well. So that that can be frustrating for them because they are not seeing the benefits early, right? And cost and complexity. So this is again a challenge because you may need to upskill the teams, educate them, train them, hire data product owners, build new pipelines, decentralize because previously data was centralized, and overhaul the entire data architecture. So this entire activity, right? So uh, it can cost a rise. It costs the rise during the transition that we are having, and especially if the old and the new systems must run in parallel for a particular time. So then that cost complexity will be kind of evolving. So that is also cost and complexity is also involved. So these are the typical challenges that you can see when you're implementing the data mesh. So hope this entire particular video was kind of content that was very helpful for you. So with the analogy that we have taken, right? So with that analogy and explaining the architecture, right? And also seeing the key principles of data mesh and this particular analogy, how we were able to map this with the cloud kitchen or the franchise model kitchen that we have seen, right? So hope this particular video was helpful to kind of understand what is exactly the data mesh. So data mesh, we will be bringing up more technical details about data mesh in the future videos. So if you want to stay connected, we would request you to please subscribe and also like and comment your opinions and the suggestions in the comment section. Hope this was useful and thanks for watching.